Yeah, that's the last page there. If we get to the very, very last one, I'll print it then. But between now and then, you can hold off on that. Yeah, yeah. Oh, I heard a ding dong. What's going on here? Oh, yeah, Janai. Hey, Janai, how you doing? Good to have you on. Okay, yeah. We're now going to start starting. Is that enough?
Okay, I'll just sketch it.
Sure. All right, evening, folks. How are we doing today? We're great. I'm glad to hear that. So just by the way, welcome to November. So 2 months have gone, so you have 6 months till CSEC. So we have work to do. So let's get down to the work, shall we? So yeah, 6 months. And you have plenty of things to learn and plenty of things to revise. Okay, so we're dealing with circle geometry, and as we have been seeing, basically the name of the game, Enjaziri, is to put on your phone and watch your screen since class start. Yeah? Okay, cool. Yeah, so the name of the game is basically visual recognition. Now, of course, it not only draws on your ability to remember and identify the specific rules, the new rules you have learned about some angles being certain values or the same in certain contexts, right? Sorry, give me 1 second. Yeah. Right, so we have these ones. So we have the angle in a semicircle is 90 degrees. So a semicircle is what fraction of a circle? Is a half a circle. And what do we call the line that cuts a circle in half? A diameter. And it must pass through the center of the circle, right? So always look for that. So the angle opposite the diameter is 90 degrees. And the triangle must be such that all 3 of the vertices touch the circumference of the circle, right? Next, we have the cyclic or cyclic quadrilateral. And the rule is that the opposite angles are supplementary. They add up to 180 degrees, right? So the 2 yellow angles add up to 180 and the 2 blue, right? And there was an addendum here. If you produced one of these sides past the circumference. Oh, and again, please do notice that all of the vertices must touch. Yeah, all of the vertices must touch the circumference, right? As 1, 2, 3, 4, right? So the addendum here is that the exterior angle of a cyclic quadrilateral is equal to the opposite interior. All right, and we have this one. We have the what I like to call the double triangle one. Although the first one looks like more than 2 triangles, so we could take out the extra. All right, so when you have these kind of 2 triangles, such that they kind of meet somewhere on the inside, not necessarily the center of the circle. We hear now. Is your voice I hear? No, nobody. Yeah. All right. Cool. Right. So we have in each triangle 2 of the vertices touch the circumference, and they share a common middle point. Well, not middle. They share a common third point somewhere on the inside of the circle, not necessarily the center. And it can be kind of skewed to one side. You could have one small triangle, one big triangle, right? They could kind of both be choked up in one corner of it, right? Angle. So this particular rule, right, says the angles in the same segment standing on the same arc are equal. So you have different ways you could see it, all right? And then, of course, you have the kind of big one here with a few different visual presentations, right? So the angle at center is double the angle at the circumference. So this particular presentation I like to call the arrowhead. because it kind of looks like an arrowhead to a certain extent. And notice that the angle at the center is 2 times the angle at the circumference, right? And again, 3 of the vertices touch the circumference and 1 is in the middle. So if you kind of rotate this down here, it'll look like this, which I like to call the baseball diamond, right? And in this case, the angle at center is on the outside of the quadrilateral. Same thing here, look at it. It's on the outside of the quadrilateral. Here, it's also on the outside. Right, now this is not a cyclic or cyclic quadrilateral. Why? Because not all of the vertices touch the circumference. You have that point in the center of the circle. Right? And in this one, it kind of spidey squinted or whatever you want to call it. Right? So again, it kind of looks like the 2 triangles, but the very important thing is that this item is in the center, not on the circumference. Right? Okay, so we did quite a few questions. They started off kind of easy, and what we are seeing is that we have to be able to identify the rules that we are using in order to justify our working and to get the marks, right? And as we've seen, we have to be able to sometimes see lines that are not there, as in draw them in, and in some cases unsee lines that are drawn in to kind of declutter the visual space. All right. Okay. All right. So Wednesday? Oh, okay, cool. Right, and of course, in this particular case here, we had these little strokes on the lines. What do those little strokes mean? That the lengths are equal. So in this case, we had an isosceles triangle, right, where the base angles here were equal. And of course, this side and this side were also equal because of those 2 little double strokes, which means that this angle here and this angle here were equal, right? So even though they don't look like that, you have to go with the information presented in the question. And you could pull out pieces of a diagram and do the working separate. Right? So some of them were kind of easy. Some of them, same thing. I took out the lines in the middle here to make it easier to see some of the things. In one case, I took out half of the diagram so you can see just the triangle, right? So of course, you're not going to be afforded that luxury when you guys are doing the actual question. But we're doing it here to help you be able to see these things. All right? Page 10. Right? So we had a cyclic quadrilateral, which kind of turned into a triangle when you took out that piece there. Right, that itself actually is a different circle geometry rule, by the way, but not one you'll have to know. It's not on your syllabus. Right, okay, so now we come to, we still have a couple more. Right, so we had this interesting looking diagram here, and a lot of times we forget that if a straight line starts in the center and goes to the circumference, that's called a what? A radius. And in any given circle, all radii are of equal length. They are equilateral. No, so I shouldn't say that. Right, this one here I kind of messed up by giving away the answer, but anyhow. Okay, we'll come back to that one last today because that one's a kind of weird one. Right, so you guys would have these things printed. I tried to print them before we started. Right, so what you'll do is you'll draw in the information and you'll have to find the marked angles or the identified angles. Right, I'm gonna have to zoom in here so I can see these things a little better. Okay. Right, so we have some vertices A, B, C, and D. Right. Yo, brother. No, there's your brother here. We here. Yeah. Right. So we have an X here. We have a Y here. And we have a Z here. So the whole angle is Z. Right. What else we have? We have some little strokes on the lines. I'm going to tell us something. Hey, Bunny, good evening. How you doing? Good to see you. Right, so you have a single stroke here and a single stroke here. And what does that tell us about those 2 particular lengths? Nothing? Okay. And we have a double stroke here and a double stroke here. Oh, and we have one marked angle. One angle for which we have the actual value. 54 degrees. Okay, so we have 3 angles to find. We have one angle given to us. Right? Now, you don't have to go in alphabetical order. You could find, I think the easier angle to find here is actually y, but that might just be me. All right? You could find x. And after you find y, how do we find z? Okay, we have a couple different ways you could do that. Because it spans the whole angle. It doesn't just span this piece on top here or this below here. It spans the two pieces. So like if I take out that line, the whole angle there is z. Sorry, what? That's the question. Z is the whole angle here, and x is just this piece. So I'll give you a few minutes to play around with that. All right?
You have like the rules that you want to now? You have the rules from something now? Okay, I'll print that one for you as well. Okay, so to start off with y, that means y is a thing that has else, but the first rule is that opposite angles and then hypotenuse rule, which is basically a square and a circle, are supplementary. So this angle plus y is going to equal to 180 degrees. What these lines mean.
Yeah.
But this is, so y was 126, because it's 180 minus and then with
What happens if you have the rules to look at?
these lines, that is
Maybe in the chat.
so this angle, that equals that, which is the angle.
you find
Are gonna be equal. But this isn't gonna be 54, because this includes.
Right. So I would take this line up to this point.
No.
And then I would take a separate element. 180 minus
It's
126 is 54.
so they're
But it is not
180
equal
degrees
to
in triangle.
54.
So these two angles are gonna be equal. So this is 134. Yeah. So that will be how you find x. And then yeah. So x is the one. Yeah. But make sure when you're doing this, you write down the rules for why you want to the answer. And kind of see division, and then for z, well, yeah, how you're gonna find z is same, you know what y is, it'll be the same kind of concept. This angle and this angle here are gonna be equal, so you subtract 126
151 plus, okay, right.
180 to find these.
So you found
And
that
then
this
you
is,
just
that was the one,
put
that was the
x
72.
is- okay.
That was,
Well, you'll add.
that was 72. Okay,
you'll
that's
add-
right.
You like understand what I'm trying to say? The angle right here. You're
Right,
gonna add
so
like
now-
64 to get the full thing.
If you imagine that this line
Okay, cool.
goes, but this is
Number
right,
back,
What's
zero
that, the quadrilateral?
for each line.
it was four sided shape. It's like a ball of 4 degrees.
Okay, so
The rule is that
you use
opposite
another
angles are
rule.
supplementary.
So this is,
Which
so
is
this
they
little
have to
kind of square diamond.
Right, so we have to
Right,
okay,
is
this line.
basically a set of
And after you find that, you can use the fact that these two sides are equal.
this plus this.
Which makes this an
So
isosceles
one
of line.
easy. Oh, and yeah.
And that's from what you say.
And then I guess you could check.
Sorry, yeah, let's pop in here for a second. Sorry, guys. I was just checking around the class to make sure we're going okay. All right. Right, so Google Meet. I have D'Angelo, Donovan, Jair, Janai, and Logan. All right. So I'll give a few minutes again because it's the first question, so I think people forgot how to do some of these things.
And then there's 180 degrees in an angle. So you'll add these two together and subtract it from that is a 54 degree. 54 would be just this angle right here. This doesn't include this thing. So this angle is, once you find x, it'll be x plus, you from this, since this is an isosceles triangle, this angle and this part would be equal to each other. You found the y is already, so you can see it will be divided. So, and then you would add that with x to get equal. Do you like understand the division? What I meant by that? Okay.
I would say divide this by 2.
So,
So this is 54. See?
so find x first. So x. Okay. So this like little. This side, this angle would be equal to x. So we're gonna be the same because it's my isosceles triangles.
This.
So this angle,
Mhm.
this angle are the same. But you see that
Yep.
they're also two.
Ah!
So this is also an isosceles triangle. So
Those are this
you
bracket.
wanna, so to find that.
I would say multiply by 2.
Are you still to find this?
Multiply by 2.
So the same concept that you would do
Used to have
y
it,
to be
right?
Which other one? 54.
This angle,
X. Okay, well, yeah,
But
we're
this
gonna
piece here, this piece like
add
on
one
this
equal
triangle.
minus one.
This piece
So
like
then
this
you
triangle.
divide this by 2. Probably 126 divided by 3.
By 3.
And 2.
Well,
None of the
154 plus
above.
154, because.
What is some of all the angles in a triangle?
Wait, sorry.
One eighty. If this is 124, 126, okay.
This is 54.
Find
This
your
is
meter.
also
And because we know that this is an isosceles triangle,
So add the 2 of them and subtract from 180.
add the 2 over.
And then 183 is further now.
This is
So
a
this
triangle.
angle is gonna
This is
be
an next triangle.
plus.
Oh, my bad.
What I'm saying is that if you consider this
So that's
triangle,
for this.
if you add up these triangles, you get
So
180. Because we
then
know
the
that
answer
isosceles
is
because it doesn't show
one
these
of
two angles don't equal.
because, or this one.
If we take
Because
this
they're
from
both gonna
180,
be equal.
we will get the
This
sum of
angle
those two
and this
quadrants.
angle.
And then just divide by 2 to find each one.
So these are gonna always be equal.
Before you do this,
So in order to find what both of these are, you're gonna have to also make it degrees in a triangle. Subtract this angle, 126, and then the remainder, you're gonna divide by 2.
put 72.
And then whatever you find for this, you're gonna add this value with the 54. And then the follows it.
Because
Uh-huh.
Okay, okay.
Alright.
Yeah.
Alright. You're ready for your video.
Yeah, you don't speak anymore.
Oh, that's not good thing. Right. Michigan, that's good.
Yeah,
Can you hold on before Kayla tomorrow again?
yeah, sure.
Okay.
Gosh, yeah, I got you.
What's that? Nah. Oh, you good. Yeah, we good. Come and take them. Can I buy it? Oh, just have it. Yeah, yeah, yeah. He's over there, you know. We take it roll call.
Gosh, that's supposed to put family family.
Alright, cool. Great job. Alright, right, so we should have two. Alright guys, I'm gonna starting here.
I told Rosie putting and then it was 3 different. 2 different triangles.
Good. Alright guys. Okay, so I wanna starting here. If you're still working, that's fine, but let's see if we could demystify some stuff. Right. So first things first, I think the easiest angle to find here is actually y. Let me show you why. So if we disregard that information, what shape do we see coming up on the screen here? The cyclic quadrilateral. And in a cyclic quadrilateral, yeah, you're good, right?
I misplaced
Cyclic, CYCLIC. So you can take a cyclic, right? Cyclic, right? And the rule with the cyclic quadrilateral is that the opposite angles are supplementary. What does that mean? They add up to 180 degrees, right? So what we could say here for angle Y. Now again, the way I lay out my statements is not the single correct way. There are different ways, but I'm walking around looking in your books and I'm seeing some statements just thrown there. So you have to be careful how you put your statements, guys, right? So I'm going to offer a couple different ways. So, all right. So for angle Y, because we know that Y plus 54 is 180, we could literally say that. We could say Y plus 54 degrees, oops, that's a big degree sign, boy, right, is equal to 180 degrees. Right. Now to find Y, all we have to do is therefore subtract 54 from both sides, not so? So we can say therefore Y is equal to 180 minus 54, which is equal to 126 degrees. Don't forget to put your reason, right? The reason is you can put opposite angles of a cyclic quad are supplementary. right? Which means that they add up to 180. Okay, now the next thing we can take a look at is as follows here. Imagine for a second we get rid of that. What shape we see in there? Inside the circle, a triangle. And those little orange strokes indicate what about those two lengths? They are equal, which means we have what type of triangle appearing here? Isosceles, very good. Which means that this angle across here is also 54 degrees. So can we then, therefore, find x? Why? Because the sum of the angles in a triangle is 180. So if we have 54 and 54, we're missing x, we can simply add them together and subtract from 180 degrees. Right? So we could even say that. Right. So we could say for angle x, oops, trying to get an arrow going there. Right, for angle x, so x plus 54 plus 54 is equal to 180. And we can put a little asterisk here. Very bad looking asterisk. Right. Right, so 54 and 54 is 108. And now to find x, all we have to do therefore is subtract 108 from 180. Right, now we have two rules here to cite. Give me 1 sec. How much room we have on that side, boy? Give me 1 sec. 100? Okay, cool. Right, so one of the rules we have, actually, yeah, that's fine. One of the rules we have is that angles, so this first one here, right? So hold on, we put a little 1 and circle it, and then a little 2 and circle it, right? So rule 1 is that base angles of an isosceles triangle are equal. Right, and the second rule is that angles in a triangle sum to 180. Right, so those are the two rules for angle x. And now to find z, so z, as you could see, exists in two triangles, right? Now, you could say if you take out this line here, it's one of the angles in the cyclic quad, but we don't have the entirety of the angle to which it is opposite. But we could find that, right? But as easily as we could find this piece here, we could just as easily find this piece across here. And because we know that this piece is already 54, it's just a simple matter of adding the angle on the top and the angle below. Right. Let's go back to 100. Right. So let's the other line going there, right? So for angle Z, we could put it as 54 degrees plus 27. It's 27, right? And we could put a little 1 there as well. Or if you want to just keep, you could put a little 3 if you want. And that's 81 degrees. Right? And then you could explain the little number 3. Right? You could simply put that was equal to 180 degrees minus y, then divided by 2. Right? And we know y was 126. That's 180 minus 126 all over 2. So that's 54 over 2, which is equal to 27 degrees. Right? And to explain why, hold on, right? Yeah, sorry, and you could also cite here that rules, sorry, not rules, but reasons 1 and 2 also apply here. Also apply here, right? Reasons 1 and 2 being the base angles of an isosceles triangle are equal, That's why we divided by 2. And then the rule 2, where angles in a triangle sum to 180, is why we did 180 minus 126. Right? Because, I'm doing this topic quite some time now. And writing over rules that you just wrote could get very cumbersome very quickly. Now, granted, when you guys are in the exam, it might happen once or twice, so it mightn't be such a big thing. But at least in here, I will allow you all to cite previous rules if you number them correctly. But again, I will stress that if you do not cite your rules, you do not get all your marks. Even if it's 1 mark for the answer, you'll get half if you don't put your rule. Right? So these written reasons, they carry marks. So respect that fact if you want to get as many marks as possible. Okay. Jaco and Khalifa and Zian, are we okay with this first item here? Any questions? All right, cool. You done, Noah? We go with that? Paige, Nyla, Shamo, Jaziri, and Josiah. We okay with that? Nyla, we good? Okay, cool. All right, D'Angelo, Donovan, Jair, Janaya, and Logan. If you guys are good with the solution on the screen, just kindly give me a Genie chat. If you need me to re-explain anything, everything, let me know. All right. Sorry, Jair, I know seeing your question here. Let me take a look. No. Yeah, no, that's not correct. Sorry, no. I had one and people borrow it and they forget to give back part to borrow. So I just constantly be losing items. Anyhow. Yeah. Jerry. So the reason, Jerry, is because if we zoom back in an isosceles triangle, right, the angles opposite the sides that are equal are themselves equal. All right. So since this angle was not opposite and equal, one of these sides that were equal, yeah. Okay. All right. So hope it makes sense now. All right. Cool. Okay. Cool. So we tie up that one. That's number 17. So let's go on to number 18 and let me give you the information. Everybody should have if anyone doesn't have a print out of number 18, let me know. I'll print it out for you. I have an extra copy here. So we're gonna zoom in here and put in the info. All right. So this is A, B. Sorry. What's that?
I didn't realize I had 3. I thought it was all the questions.
No, yeah, I put them because I wanted to explain each one separately, but I just ended up doing the whole thing. So, sorry. All right, now that point X is not the center of the circle, eh? Okay, so, oh, wait, what question going on here? Sorry, what? Yeah, X is not the center of the circle. Apparently I erased a couple lines that I wasn't supposed to erase. So you guys are gonna have to draw in a couple of lines in the diagram. Sorry. Right. So you have to draw a line from B to C. And a line from A to D. Okay, cool. I don't know how come I left those out. Sorry about that. Right, so we have one unknown, which is X. We have a second unknown, which is Y. And we have 2 marked angles. We have a 60-degree angle down here. And we have a 25-degree angle here. But 1 sec. So what might help here is if you, so we have a couple of double triangles here, right? So we have that kind of version there, which means that these angles here are equal, and these angles on top here are also equal. But they're not helping us. All right. What's that? But if we tilt our vision 90 degrees, we could see we have another case of double triangles. And what do we know about the angles in this double triangle situation? The angles in the same segment are equal, or the angles standing on the same arc are equal. Yep. So therefore, what would x be equal to? So x would be equal to 60, and y would be equal to, correct? And the reason for both of them is because angles in the same segment, standing on the same arc, are equal. All right, so again, sometimes you have to unsee certain lines in order to be able to see the answer a bit more clearly. Right, so that was basically all there was to question 18. There wasn't anything else really to do, to be honest. Right, there's no big sort of working. Again, so again, some of these rules are pretty easy once you could remember them and once you could spot them. All right, and that was all the question I wanted, to be honest. All right. Okay, in class, people, any questions? Anybody, anything? No? All right, Google Meet, just give me a quick G in the chat if you're good with that. If you need me to re-explain, please give me an R. All right, cool. All right, give me 1 sec. Let me put in the info on this question. So this one is a little more involved. Yeah, sure, no problem. They're in the chat. Yeah, they'll be in the chat. Yeah, I'm good, sir. You're good? All right, cool. Yeah, if you go to last week Wednesday, you'll see the PDF for the end of class. Yes, we did. You weren't here. I remember that. I don't know why. But the previous Wednesday is when my wife went into labor.
Oh, and last week.
Right. So give me 1 second. I have to pull from the actual textbook for this. I don't know what happened to the question from last year. Right. Now, this point here, this point O is the center of the circle. All right, so I have a couple of marked angles here. Hold on. They want BAC. Hold on. You have to find the following. Yeah, sorry about the scrappy writing. I'm not sure what's going on with the point. Right, and we have a couple of marked angles as well. We have that this angle down here is 35 degrees. And this angle here is 65 degrees. Hold on. So we are given at angle CAD is 35 degrees. At angle BCA is 65 degrees. Right. So don't forget O is the center of the circle. Right, so I'll give you a 5 to 7 minutes to see what you could sort out there. And we'll start talking. Right, now if you're not sure which angles we're looking for, this is how they often ask you to find the angles on the paper. So check it. If you're not sure, BAC, following letters. BAC means that this letter here, right, that angle there is angle X. ACD. ACD means starting at A, going to C, then going to D. So it means that this angle here is the angle Y we're looking for. And AED is this angle here, which we'll call Z. So again, I'll give you some time, and I'll give you a little hint in a couple minutes. Yo. Just you. But you never know. It might have other people feel the same way. Ask yourself if the fact that they gave you the center of the circle has any significance. Oh, by the way, the question you messaged me about with the bearings, you got through it? Yeah. All right. Yeah, that was from my paper 3. Yeah, so Shimo, you said that yes, the fact that they gave you the center of the circle has some significance. What is that significance? Well, I don't have to do with the center, but okay. Well, in one case, sorry, but that's not lining up here. You would have to have two radii coming from the center. That would look like this one here. And I don't think that's what's going on here. Yep, that's it. So this line AC, is it not passing a straight line passing through the center of the circle from one point on the circumference to another? And what do we call that kind of line? A diameter. A diameter cuts a circle in half. Half a circle is called a semicircle. And the angle in a semicircle is 90 degrees. Right? So that, well, let's take a look. Let's put in a S4, right? If we take out this piece here, right? I take out this piece here. What angle is 90? By which letter? By B. That's 90 there. Similarly, if we put O here, and you have A, B, C, D, and we take out this, isn't that also a semicircle? Have a 90 degree here. So we have two 90-degree angles. Yeah, the whole of B is 90 and the whole of D is also 90. That's correct. That's 90 out there. That's it right there. Imagine this line wasn't here.
How's the line that you were talking about?
This is 65 here. This is 90 here. This is somebody down the ground.
So yeah, I need two of them.
No, I don't know that for sure, but it's kind of So the next thing that I would do is so in order to find x under
Set your rules there.
yeah, but it's on this corner, not this one, not this one. So you'll switch both of those to get x. 55. No, yeah, so 55. Well, this, no, it's actually 20, but do you see how it's 25? Yes, it's all, it's all 98, 65, yeah, but it's subtracted. And then we see the concept for
I need you.
yeah. Okay. So the person what?
You don't need that, just need yours.
You need to Well, how I found that was great. This angle and this small one pair of equal. Because it's little spine. Yeah. So you have this angle. So you have this angle as well, which is so I have but the ends and equal to each other because they're vertical. I'm waiting for over there.
It took a long while. This is the same reason, right?
I swear.
Yeah. Technically, because think about it. It's really what's happening by the rules.
Okay, so y, so 180 minus 125 is 85. And then, for when you're looking for Z, what I didn't find was, okay, so you know with the little spiny rule, this angle, 35 is also going to be
Yes, yes, yes.
You know what? This are
You what?
together. So you have 35 plus 35. So.
I thought you said you get one. I can't go.
Well, this plus this minus 100 really down.
Why would we?
You found E? What was that? I mean, sorry.
So you find X now and she's
Oh, go on. Alright, what Z exists in that triangle, right? So if we have this angle, then we define it. So you have 55 times Z.
How I found that? I find 80%.
Nope.
This angle and this angle are both gonna be 35.
Huh?
Because these are gonna be. Yeah, I remember I gave this is 65. I found E by adding these together. E's gonna equal exactly.
Sorry. Oh. Hey Javier, evening, how you doing? Yeah, sorry, I hope I don't have to wait. I was walking on in class checking some work, hope I don't have to wait long. Uh-huh. Oh, okay. Well, that's happened. So we finished trying to finish off the exercise here that we started last week. So this is third question for the evening. The second one was kind of easy-ish because it was you think kind of double triangle rule. So angle x was 60 and y was 25. The first one was a little more involved. All right. But we here now. So I'll give it about 2 minutes again, and then I'm gonna go through the reasons, right? Right. So the others on Google Meet, of course, if you all have any questions, now is a good time to ask. Oh, sorry, I don't see any here. Innovations, okay, yeah, no worries. Whoops, careful. Right, there we go. All right, folks, let's take a look at number 19 and see what's going on here. Right, so like I was saying, if we right, if we deleted the kind of bottom half of the diagram, we would see the right angle triangle, right? Because again, once again, remember, right, this line here is a diameter. A diameter cuts a circle in half. Half a circle is called a semicircle. And the angle in a semicircle is 90 degrees. Right, now we are given this 65-degree angle here. So to find x is actually a relatively simple matter. So x would be equal to 180 minus 90 plus 65, which will give us 25 degrees. Anybody? Yeah? All right. Cool. Hey, I see. Good. How are you doing? All right. Now you have... Sorry, yeah, go ahead. Jerry, a question? No? Oh, okay. All right. So yeah, again, I have a couple of different rules here. So I'm going to cite item 1 and item 2. Right? So the first item I'm citing is that the angles in a triangle sum to 180. Right? So angles in a triangle sum to 180 degrees. And item 2 is that the angle in a semicircle is 90 degrees. Maybe he doesn't realize that he's unmuted. So let's help him out there. Right. So that's the first unknown that we had to find, right? The second one was angle Y, which in the diagram is here. So again, if like in the first question, how we disappear the bottom half of the diagram, if we disappear the top half, guess what? We have the same thing, right? Because this line is a diameter. It's a straight line passing from one point on the circumference to the next through the center, right? Which means that the angle is a right angle. So we're looking for angle Y, and this angle is 35 degrees here. So all we have to say here, therefore, is that Y would be equal to 180 minus 90 plus 35. And that'll give us, I think, 55 degrees. Anybody? Right. And we could say that the rules 1 and 2 from above apply here. Rules 1 and 2 from above apply. Right. The last item we have to find is angle Z. Now, angle Z exists in a triangle. Hold on, man. Right. It exists in this triangle here. Whoops. Okay. And what do we know about the sum of the angles in a triangle? Equal to 180. Now we have one of the angles, but we don't have the next one. But we could very easily find it because if you kind of disappear this line here and this line here, are we seeing our kind of double triangle Spider-Man thing? So it means that this angle down here is equal to 65 degrees because angles in the same segment are equal. All right, so that's Z. All right, cool. Well, I don't have a third instance of the diagram. Hold on, let me zoom out and see if I have it. No, I don't? Okay. Oh, God, pressuring that way. I'll just go on top of here, right? So 3, right? So to find Z, I would say 180 minus 35 plus 65, which is 100, and 180 minus 100 is 80 degrees. Yo. If I take off these lines here, this angle here and this angle here are equal. Right. Right. I'll put a 3 here. Right? So we could say rule 1 applies, right? Rule 1 applies, which is the sum of the angles in a triangle, right? And for item 3 is that angles in the same segment standing on the same arc are equal. Right. Hey, Petegi, how you doing? Hope I'm pronouncing your name correctly. Right. Right, so that's angle X, angle Y, and angle Z. Okay. Z, and talk to me. You okay with that one there? All right. Khalifa and Jaquan. Any questions? Anybody? Anything? Sure? When you're ready, let me know. Jay, talk to me. Uh-huh. Move it.
Yeah, no, because I thought that you could do it as like a straight line where the whole line has the 180.
Okay.
This angle here, and the angle you found it by.
Okay.
Add those two and then subtract it from it. But that I was saying
That's not gonna work. Because they're two separate angles. If there was some kind of parallel lines and you could use F angles or something, maybe. All right, Google Meet. If you guys are good with the solutions for X, Y, and Z here, please give me a G in the chat. If you need me to re-explain any or all, let me know. Uh-huh. Right. Sorry. Oh, yeah, that's it. That's all. Right there. Right. So 1, 2, 3, 4. So 4 people out of 6. Okay. So you're missing a couple of people. All right. Right. Yes, we're finding the angles. We had some angles to find here. X, Y, and Z. So we're using the rules of circle theorem to help us to find those things. All right. Okay. So they could be a bit tricky to see sometimes, you know. So we're learning how to do so. Okay. Cool. Okay. All right. Question 20 now, ladies and gents. So I'm just going to zoom in and put in the information. Give me a couple seconds to do so. Oops. Come back. here. So first things first, this point here, O, O is the center of the circle. All right, so we have P, Q, R, and S. And this point here is point E. Okay, so we have a couple of marked angles. Hold on. Let's see what they want us to find. So we have to find PRQ. Right, we could call that let's call that small a. We have to also find RPS. Which we will call small b. We have to find RES. Which we will call small c. Right? And we are given QPR 57 degrees and PRS which is 29 degrees. So I'll put them in. Thanks for sharing live. So I'll give you a couple of minutes to see if you can make any headway. All right. If you're not sure where the where A, B, and C are on the diagram, let me know. Yeah, it's from the textbook. So it's not that I'm giving them labels, but yeah, I'm giving them the labels from the question in the textbook.
That's really easy. It's actually the same question. Yeah.
Yeah, I'll watch out. At the end where it's bad. No, it's not bad. It's just like every time I clear my head, it's just fully fearful. It's not bad.
Yo. That's correct though. That's correct, yeah. But because of these things. Second. Yeah, well, this is the one from second down. This is like that's it. This is one thing about this what are they ignore this?
So this tiny angle right here is going to be equal to this one. So this tiny angle here is also going to be equal to this. 27, 29. And minus both of that angle together. Yeah.
It's like your rules for this one. Explain why that goes 57 dollars. Make sure it's like your rules. Otherwise, I'm not gonna get along. What are we doing again? This is the getting a little bit. I've seen a bunch of arrows. What's going on there? Janaya. Right, Janaya. Janaya asleep on her keyboard or? Let's see plus, minus, plus, minus, plus. Oh, okay. No problems. I was just wondering what going on. Is it 33? Yeah, 33 is an answer there. Alright. Okay, guys. Let's take a look at what's going on in this one here.
Right. So again, yeah. So if we once again acknowledge that this line here is a diameter because it's a straight line in a circle from one point on the circumference to the next one, passing through the center, it's a diameter. And a diameter cuts a circle in half. So if we kind of disappear this for a second here, we have two semicircles, right? Well, two triangles, I guess you could say, right? One on top and one below. So the angle at Q is 90 and the angle at S is also 90, right? So this here, sorry, is 90 and that's 90. Right, and we need to find PRQ, which is this angle here. And we can see it's one of three angles in a triangle. So we can say, okay, well, that's simply 180 minus 90 plus 57. That's going to give us 33. Right, now we have some rules to cite. Right? But if we check out RPS, which is this angle across here, we see that basically it's flipped, right? What we just did, it's the exact same logic down here. We have a 90-degree angle, a 29-degree angle, and we have to find the third angle in the triangle. So the logic is the same. 180 minus 90 plus 29, just 61 degrees. Right? Yeah, I'm not kind of small there. Let's just give me a sec. Let me put in my rules, right? So for both of these, we have two rules. So rule 1 is that angles in a triangle sum to 180. And rule 2 is that the angle in a semicircle is 90 degrees. All right, so RES, that's the most different one. But if you remember the question just now, if we were to disappear this piece here and this piece here, are we seeing the kind of double triangle thing? Which means that the angle down at S on the inside there is also 57 degrees. All right, so this angle here is also 57 degrees. Which means we are looking for this angle here, which is, well, C. I have it kind of marked as E, but yeah, that's C. And then, of course, well, it's the same logic, right? The sum of the angles in a triangle is 180 degrees. If we have two of the angles in the triangle, we simply add them together and subtract from 180, right? This one here is a different rule. This one, right, is that angles in the same segment standing on the same arc are equal. Okay, well, I guess I could zoom out there. Right? So that is, I'll put that as 3. Yeah, so quite a few of you all who I saw had that working, but you don't have your reason cited. And again, if you don't have your reason cited, it might look like it took this 29 and this 57, added them together and subtracted from 180. Now, obviously, that's not what you did, but if you don't cite your reasons, that's what that's going to look like what it is. Right? So the angles in the same segment standing on the same arc are equal. Some all the names sometimes, boy. Okay, in class, people, have you any questions on how I solve for any of the angles, any of the reasons working? So for angle B, the green angle, right? So let's take out this.
I see in the 90 degrees, right?
Uh-huh.
We need to use the same reason.
Yeah, it's the same exact two reasons. Okay. All right, Jaquan, Khalifa, any questions on this item here? Zian, you okay with it? Noah, talk to me. You all right? All right, Nyla, Paige, you okay? Right, Josiah, Shimon, Jaziri, talk to me. Yeah? Okay. All right. All right, Google Meet. So I see Javier jump in first. All right, so thanks for it. So Google Meet, if you guys are good with that, just kindly give me a G in the chat. If you need me to re-explain anything, let me know. Give me an R. All right, so 4 out of 6. Next two, let me know what's going on. If you need help, let me know. Okay, we're going again. Question 21. Give me a sec. Okay. All right, so we have P, Q, R, S, and then X on the outside here. SPQ is 75 degrees. PQR is 85 degrees. We had to find angle small x. You understand RES? All right, one second, guys. All right, to find RES, we have to kind of focus on this triangle. Hold on. On this triangle here. Right? Now we have a 29-degree angle there. And the 57-degree angle here was equal to this. Right? And that's the rule where we have the kind of what I like to call the double triangle rule. Angles in the same segment standing on the same arc are equal. Right? So again, if you come back down to here, right? If you kind of disappear this, you disappear that, and this, right? We could see that this angle and this angle are equal based on the rule, the protocol, the theorem, right? So that's hopefully helpful to you. Okay, yeah, sorry. So we had to find angle X there. Let's see what you could come up with. Well, you have a couple of different ways you could do it, huh? Right, that's fine by me. One second. Question 3.
course.
There's no question.
Yep. Oh, you understood? Okay, good.
Yeah, so the exterior angle is equal to the opposite interior angle. Because you know how this is supplementary, so it will be supplementary. On there, because it's a supplementary, so you're equal to 180, and this is also a line. So you take away the same thing from 180 degrees. So the same concept over here. So if I subtract, sorry. Yeah, because angle and straight line. You see the division of 45? So, in
Will give us what? Yeah, for R? Yeah? No problem.
opposite angles are supplementary as like a quadrilateral, and then at the same time, this whole angle on the line is 180. So technically, both of these angles would be taken from 180. So that's why these would be equal. So the same concept with this S here, this outside angle, or also angles along a straight line is 180 because it's a semicircle. Kind of same vision, correct? So that's how you find this angle right here. And then angles in a triangle are 180. You have this.
I went to move from so what I'm trying to
Okay, right. Okay, so one of the rules that you would have seen, I don't know if you would have seen is the outside exterior angle is equal to the opposite interior angle. Because these two are supplementary. And then, so basically, all these angles you be taken away from each to the equal. Because if you take the 105 from 180, you'll see it. And this angle will be equal to this angle right here, same thing. Or also, we subtract 85 from 180 to get the opposite angle. And there's two together here, because you have both these interior angles.
Right, I'll give a minute or two again, then I'll starting here.
Okay. So generally it's a rule that the opposite exterior angle, so this angle here and this angle here, will be equal to the opposite interior angle. So can I do that? So this angle right here will be equal to this 75. And then this angle here will be equal to this 95. Or if you want, these are both on the straight line.
Sorry, even though
you
you're-
can make one.
Yeah, you're gonna correct just now.
And then you have the two interior angles of this triangle, 180. So you find out, take those with the 185x. Okay. Okay, so. Okay, so 95 is, okay. So how do you get these interior angles? Because your also the opposite. So the exterior angles are equal to the opposite interior angles.
Yeah, Mara.
Yeah, and this is 95.
Mara from a Form 6 class?
Yeah, 95, and then, yeah, so but you're going good for the same concept. So this is just supposed to be 95, so your answer would be 10 instead. See the vision of how,
Somewhat.
Santi, boss, what are your vibes?
Okay, so there are two ways you could do it. Okay, so this angle and this angle are always going to be equal. Yeah, so that would be. Or another way that you would remember it is opposite angles are supplementary, and obviously you take away this angle from 180 to get this. So it's the same taking away 180 for both of them. And then these are supplementary as well, so that would be 95. Or take it away from the semicircle. Yeah, so that would be 95. And this would be 95 as well. No, this will be 85 here. The outside exterior angle. So this one. So same concept of this and this being equal. This and this would be.
Those are more than 95 and inside 85.
And then we have the two interior angles of the triangle. So you just have to find this last one by adding these together and subtracting. So you get 10 for that. See the vision of this one?
All right, guys.
Hey.
All right. So let's take a look and see. So, here's my question, right? In this, apart from the circle, what shapes you see in the diagram? The cyclic quadrilateral and a triangle, right? Was it sum of all the angles in any quadrilateral? The interior angles. 360. And was it sum of the interior angles of a triangle? 180. Yeah, right. So check this, right? You want to find angle x, not so? Okay. Now, if we acknowledge that this here, PQRS, is a cyclic quadrilateral, we could use 85 to find across here, not so? That'll give us 95, right? And if we now disappear this piece here, we have a triangle where we have the two kind of base angles, I guess you could say. And if we have two angles out of the three, we could find the third one, not so? Right? Now, you could also do it in a way where you find that the angle on this side is 95, because, of course, as I heard Mishka telling you all, is a straight line, right? And the angle on a straight line is 180 degrees. And then you could use your other addendum rule to the cyclic quadrilateral one to get that this is also 75 degrees. And then you have your three angles, well, two out of the three angles in the triangle. The opposite angles of a cyclic quadrilateral are supplementary. That's rule number 2 that I taught you. Right? So if this was 85, you could find 95 by subtracting 85 from 180. Right? And then you have 2 out of the 3 angles, so therefore angle X is equal to 180 degrees minus 95 plus 75, which itself is 170. 180 minus 170 is 10 degrees. Right? And the reason for this one is that angles in a triangle sum to 180. Right? And then the 95, well, opposite angles of a cyclic quadrilateral are supplementary. Yeah, I could. But I'll have to just shift around the screen and that kind of stuff. Could always possibly get a Bluetooth keyboard and fit it somewhere. Yeah. 818 boy, better for one more. Do I want to give you all this one as a question? Right? So yeah. All right, cool. Google Meet, just give me a quick Genie chat with this last one here. Well, not this last one, but the one on the current news screen. Please not that. Yeah, so don't forget, the basic shapes are still in play, right? They don't disappear. All right. One more here for all, yeah. I'll see. Right. So that's A. That's B, that's C, that's D. This is O, which is the center of the circle. And they give you one angle here, which is 35 degrees. You all have a number 3 printed out, right? Okay, cool. So we want to find ACD and then ADO. Now check it. They want us to find ADO. But to find ADO, you have to go, and just on the screen there, right? We have to find from A to D to O, right? Which means we'd have to draw in a line from A to D to facilitate finding the angle here. Yeah. Let it go? Okay. See if they bring me balance of fees for me now. See if they brought the balance of fees for me. Yeah? As your mom said, I'll get to it. Sorry, what? Go back? All right, cool. Yeah, that's the blue and the green. Sorry? So if we disappear this for a second, right? This is a very skinny version of the double triangle. Yeah? So it means that the green angle is equal to how much? 35. Define the blue one? Alright. What's this point here? Center of the circle. This is a straight line from the center to circumference, as is this. And what is the name given to any straight line from center to circumference? A radius. And in any given circle, all radii have the same length. Which means these two angles, those two equal. So if we take out this stuff here, what kind of triangle do I have on top there? Isosceles. But so it means that these two angles here are equal. But the question then becomes, what's this angle here? And that's where, if you disappear this side here, you have your arrowhead. And the angle of the center is double the angle of the circumference. That's correct.
Because we drew any line on the top, technically the angle still be exterior of the shape. Remember, you said, yeah, the limit has to be on the exterior, not the interior.
Right? Yeah. So I mean, well, no, remember, the orange is on the exterior of the arrowhead, eh?
Yes, but just because we drew the shape, the line on top and the
Yeah. Because this is 70. And this 55. First things first. ACD is equal to ABD. Angles in the same segment.
Not surprisingly smart.
Right, and now ADO is equal to 180 minus 70 divided by 2. So we have three rules here. So we call this 1, we call that 2, we call that 3. So rule 1 is that angles in a triangle sum to 180 degrees. Rule 2, an angle at center is double the angle at circumference. And 3, base angles of an isosceles triangle are equal. All right. Center. Oh, circumference. Right, folks. So we finished the first exercise, and we have a few more rules to become acquainted with. So on Wednesday when we come, we learn about the angle between tangent and radius being 90 degrees. Next week, we'll spend a double session, well, 2 double sessions, when I say Monday and Wednesday, on 2 tangents to a circle. The week after, we'll talk about angle between tangent and chord. And in the next 2 sessions, it's past papers. Anyhow, so if anybody has any questions and they get to ask during class, please feel free to WhatsApp me with some pictures. Other than that, have a good evening. I'll see you all on Wednesday. Bye. Google Meet, I'll go on there later.